Okay. The other gas law we're going to work on is called Lussacs Law. So again, here's the worksheet that you'll be working from. And you want to have out, again, your note card. Here's Lussacs Law, where it's very similar to Charles' Law. It's a direct relationship that relates pressure and temperature. So the volume is held constant. And again, for pressure, if you see a number with ATM, which stands for atmospheres, kPa, which stands for kilopascals, or mmHg, which stands for millimeters of mercury. Any number associated with those units is going to be a pressure. And then temperature will always be in Kelvin. If you're given a number in Celsius, add 273 to convert it to Kelvin. All right, so we'll get started. So likewise, for me, I always like on my worksheet, I always like to rewrite my formula just in case. So under where it says Lussacs Law, I'm going to put P1 over T1 is equal to P2 over T2. All right, so we'll do number one together. So I'm going to read the problem and underline key information as I go. So it says, determine the pressure change when a constant volume of a gas at 1 atmosphere is heated from 100 Kelvin to 130 Kelvin. So I'm given 3 numbers, yet I have 4 variables. So for me, I prefer to list out my P1, my T1, P2, and my T2. All right, my first number, 1 atmosphere. That's my first pressure. So 1.00 atm. 100 K for Kelvin, that's my first temperature. So 100 K. My third number is 130 K. Well, that's a temperature, so that has to be my second temperature. So 130 K, which means is I'm looking for my pressure. Plus, it says determine the pressure change. So we're looking for the pressure. So it's my P2. Also, when I look at my card, Lussacs Law is a direct relationship. So both variables will increase or decrease. My temperature has increased, so I'm going to expect my pressure to also increase. So my P2 should be a higher number than 1 atmosphere. All right, so let's plug these numbers in. So P1 is 1.00 atm over 100 K, and that's equal to, since we don't know what P2 is, we leave it like that. My temperature is 130 K Kelvin. All right, so we're going to cross multiply. So we're going to do first, we always do the one that's where the two numbers are paired up. So we do 1 times 130, which we obviously know is 130. And then we're going to multiply P2 times 100. So again, I'm going to go through all the steps so how you see I can calculate, but at this point many of you can just start plugging in your calculator. All right, so how we're going to see this, I'm going to have 100 K, so this is showing all the work, times your P2 is equal to 1.00 atm, I gotta move over a little bit, times 130 Kelvin. All right, so to get P2 by itself, we have to take 100 K and divide it to both sides. So 100 Kelvin divides there, and then 100 Kelvin divides there. So this obviously cancels out, so you're left with P2, looking for pressure. So now what we're going to do is multiply these numbers. We're going to take the numerators, the top numbers. We're going to multiply 1.00 times 130. Then we're going to divide it by 100, and we got 1.3. So your answer is 1.3. And since it's a pressure, our pressure looking at our units, is either atmospheres, kPa, or milliliters of mercury. Now we just can't randomly pick them. We have to use the unit that was assigned to us in the prompt, which was atmospheres. So it's 1.3 atmospheres, or ATM. And knowing that this is a direct relationship, we've watched temperature increase from 100 to 130, and notice your pressure increased from 1 to 1.3. So that makes sense. All right, so that was an example, a correctly completed example on how to solve a Lussac problem.